Suppose I have basket or a box. And in that box, I have, let's say, thistles. A whole lot of them. And I'm going to grab a handful. And then I'm wondering, well, how many green, how many red, how many yellow could I grab from that box? Could I have grabbed from that box? So all I'm doing is choosing from a box. I don't care if I pick a bunch of reds followed by a bunch of yellows, followed by a bunch of greens. By the way, green Skittles are awful. There used to be yellow ones. I think they got rid of it. So when I grab stuff, there is no need to look at orderings. Same with, let's say you have your laundry bin and you go, you have a whole bunch of different items and you've got pants, you've got tops, and you're just taking, your hand in and you're picking stuff at random. And you're wondering, well, what are the chances that you pick, or not chances, in how many ways could you pick 2 pants or 2 shirts? I don't care as to in what order I picked. All I care is I stuck my hand in, grabbed a bunch of clothes. Go with a simple example. Now, suppose you have A, B, C, 3 letters, and you want to find orderings. So you have A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. Now, if this is the case, when I say combination, none of those matter. All of those simply would correspond to ABC. I don't care whether it's ABC or BCA or CAB. It's just, 3 items. Suppose I have ABC still, and I've asked someone to pick 2 letters out of the 3 letters that we have. I just want to choose 2 letters. Let's start with the possible orderings, 2-letter orderings that I can come up with if I have 3 letters, A, B, C. Now, I have 3 letters, and I'm going to permute 2. In other words, I'm going to come up with orderings. I have AB, AC, BA, BC, CB, CA, and that is all. Those are all the orderings, and the order matters. I'm going to introduce 3C2. Some like to call the C over here as combination, 3 combination 2, but by all means it is 3 choose 2. There, it's 3 permute 2. So I mentioned that anytime we do combinations, the order doesn't matter. So whether it is AB or BA, they mean one and the same. So I'm going to combine those two and simply write it as AB. AC, CA mean one and the same. I'll combine those two and I'll simply write it as AC. BC and CB will refer to the same thing. So I'll combine those two and I'll write it as CB. Whether I write it as CB or BC doesn't matter. So the number of combinations I have is just 3. The number of permutations that I have is 6. So I believe I did a Mexican restaurant example with permutations. Now I'm going to do one with combinations. Suppose so a Mexican restaurant has 4 taco varieties. Julie goes to the restaurant on 2 workdays during the week. And someone's wondering, so in this case, I really don't care on what day Julie is going to pick a specific taco variety. I don't care. Then on Monday she picks beef and Tuesday she picks pork. All I care is she's going to pick 2 taco varieties on 2 work days during the week, and it could be any day, don't care. And in how many ways could we achieve this? First, the order doesn't matter, since I don't care about on what day Julie is getting a specific taco. Now, so since order doesn't matter, this is a combination problem. The general formula for combination is simply n factorial divided by n minus r factorial, which is the formula that we had for permutation. We divide it out by r factorial to reduce the number of orderings, because ordering doesn't matter. By dividing r factorial, we make sure that ordering doesn't matter. I'm omitting details on this because I don't want to confuse you all. So we'll just keep it simple. N in this case is 4. R is 2. N minus R, 4 minus 2. 4 factorial divided by 2 factorial, 2 factorial. But if I wrote it 4 times 3 times 2 times 1, two times 1, 2 times 1. Those two will go away. 2 times 2 is 4. And there are 3 ways for Julie to choose 2 taco varieties on the 2 workdays Julie would go up to get tacos. So last time, to do permutations, we typed a number, then we went to math, and then we typed the value of R. So we are going to do the same thing for math, math over to PRB, select number 3, which is NCR, followed by 2. Enter. Oh, I get 6. Did I do bad math? I did do bad math. In my mind, that seemed pretty low, but again, I'm recovering from the flu. So blame it on that. 6 ways. And we obtain it using the calculator as 4 NCR2. So this problem, a hacker knows if he picked 4 out of the 20 3-digit codes that he has in a list or on a list, will open a safe. It's going for money. How many ways can he choose 4 3-digit codes to open a safe? To put this into perspective, as an example, this is what the hacker is trying to do. So those are 4 3-digit codes, and should have made that bigger. And that is a list of 20. So he keeps picking, the first 4 codes, tries it to open the safe, doesn't work, does it again, doesn't work. So he's going to keep on trying. So how many ways are there for the hacker to pick 1, 2, 3, 4 3-digit codes from a list of 20? Mind you, here, whether he chose 319 followed by 320, then 434, then 529, makes no difference when compared to picking 322, 434, 539, 319. So order doesn't matter. All you have to do is identify N and identify R, and this is a combination problem. So the hacker has 20 3-digit numbers in the list. He is going to choose 4 of them to open a safe. the order doesn't matter. In other words, he's just choosing 4 3-digit numbers to put it, you know, in the safe and try to open it. So this would be NCR. So going back to our calculator, (20) math NCR 4,845 combinations. So if you have difficulties seeing, I'm just going to put A, B, C, D, E, so forth. I'm going to pick 3 of them from that list. Whether I pick it as ABC or BCA or CBA doesn't matter. In other words, whether I pick ABCD or CDBA, in what order I pick really doesn't matter. All the hacker wants is 4 3-digit codes. So in how many ways can we choose the Powerball from 60 possible numbers? So if you have one Powerball and you've got to just pick one number, naturally, there has to be 60 possibilities. Or 60 possibilities, 60 numbers, one of which would become the Powerball. So we can do this as 60 choose 1. Out of the 60 numbers, we choose 1. Going back to our calculator, 60 math NCR 160 ways. I believe each state does it in a certain way. So first we've got to choose 5 numbers. Just choose 5 of them from the 69. So we would have 69 choose 5. The last one, we have 60 possible ways from earlier. Let's go to the calculator. 69. Choose 5. The last one will happen in 60 ways. So we know from the fundamental rule of counting, first one, if first event happens in a certain number of ways and the second happens in a certain number of ways, we simply multiply. So that answer times 60 we will have that many number of ways. Now, why do we worry about counting? This is going to lead into something called probability. Suppose someone asked you, what are the chances of winning the Powerball? So well, all you have to do is match one out of all possible ways. So all possible ways would form what we call a sample space. I'm going to introduce that in a bit. So you choose one ticket out of all possible values that you have. That is the probability of you winning a Powerball. So 1.4829, I'll round it to 1.5 times 10 raised negative 9. If I want to put this in perspective, pretty small, but then still happens.